So this is 7th week, so we have crossed the halfway mark. Yes, this is 12-week course, so we have successfully completed 6 weeks. So now entering into nice 7th week. Yeah. So should we start with clustering? Okay, so it's 7. Let's begin. So have you all gotten chance to go through the video lectures? If you have gone through the video lectures, we will quickly move to the questions. I'll just give you a brief overview. And we can't go into details of all these things. Yeah, somebody wanted to say something. Yeah, Shreya, you wanted to say something?
Yes, ma'am. Ma'am, I have gone through the
Lectures, yeah.
lessons.
Haha.
Yeah.
Okay, great. That's great. So I'll just give brief overview of different clustering techniques. Yeah. So we are still in diagnostic analysis. So we are trying to understand learners' behavior pattern based on different features which we can generate using learners' data. So mostly in this course we talk about learners' log data or learners' action data. So in log data as in logging their actions in an online learning environment, what kind of where they are clicking, and what text they are typing, what is their performance while they are attempting the questions and answers. So all those things we consider. And we can consider different features like behavioral features, if they are time spent features on time spent onto different actions. So all those things we can consider for this clustering. But so now why we need to perform this clustering actions, like why we need to aggregate learners or their data points into different clusters is when it comes to personalization, when we want to do prescriptive analytics, or even for predictive analytics, this will form as a base. This clustering activity will form as a base. So to give you a simple example, I'm kind of simplifying this whole learning and student profiling is when we want to personalize something, we have to do that, uh, tailor the content for individual learners need. But that is not always possible because of limitations of computing and limitations of physical resources which we have to support our online learning environment. So in that case, what we do is, or what most of the organizations are doing, whether it is in learning context or non-learning context, is they are creating certain profiles or some models they are creating for a certain set of user behaviors. So the same thing we are doing for students. We are for certain similar for students who are having similar set of behaviors, we are creating one cluster for them so that we can provide remedial content or some messages to them, to that particular cluster, all the students belonging to that particular cluster. And we do that in order to improve their learning within that particular learning environment. So example, like analogy from the classroom setting is, when teacher is teaching in classroom, we observe students facial expressions, whether they are understanding or not understanding. So when we observe that when we are explaining some theory portion, a set of students, they have this confused expressions. So we try to again explain that theory to them, and then maybe some different set of questions they get confused when we are solving some mathematical problem on board. So we redo that by observing their confusion. Yeah. So that means we are profiling that group of students as confused for theory and confused during the actual solving of problems, and we are providing the remedial content, or we are providing some material to improve their learning by repeating the content or by explaining it in different manner, or changing our examples. So all those things, how we will do in computer based learning environment or an online learning environment, is by creating students profile, by clubbing the students who are having similar set of behavior patterns, who are spending more time into reading, less time into video watching, who are having more mistakes in quiz, more wrong answers in quiz, who are having more wrong answers for a particular topic only. So all those features we can use while creating these clusters. So we have this two types of clusters, like distance based, which is also called centroid based, or the continuous clusters. So k-means clustering is one of the most popular clustering method for centroid based. So we have the scatter plot or different set of features, and then we calculate the distance. We randomly choose k number of centroids or k number of clusters, or unke the clusters centers who belong to that particular clusters are called centroids. So centroids will be randomly chosen for first iteration, and then we will calculate the distance of those centroids from each data point, and then closest data points will be clubbed in that particular cluster having that particular centroid. Then we will again recalculate the centroid by taking the average of all the data points which belong to that particular cluster. And so this process is iterative. Okay, so if you're confused, don't get confused, go back to
Yes,
Sir's
I'm
lectures.
quite confused. Could you
He has
please
explained
go
it
a bit
well.
slow so that we can follow?
Yeah. So that's
It's interesting, but
so that's why I always ask in the beginning whether you have watched the video lectures or not, and I will reiterate again. So these sessions are not really substitute for the video watching. Okay, so don't skip the video watching, because we can't cover entire weeks of content in this 1 hour of live session, right? So it's better if you watch the videos and then come here, so that if you have any doubts, we can target those doubts. We can't target the entire syllabus right now. Okay,
Yeah,
so
yeah,
I will
agree,
explain
agree.
this k-means again for your understanding. But
Thank you so much.
yeah, but I mean, it will benefit if you watch the videos and come and ask the
Definitely. This
pinpointed
time I couldn't
doubts.
catch up with the time,
Yeah.
so
Yeah,
that's the
I,
reason.
I, I understand. I completely understand. So let me explain how does it work. So yeah. So like we have certain data points here, some data points here. So you can see two clusters, right? So we can have two centroids, C1 and C2, over here and over here, like that.
Right.
So in first iterations, the centroid C1 and C2 are random or arbitrary. Then what we do is, all the data points, we calculate the distance. So this distance formula we have to fix in the beginning, whether we are using Euclidean distance or Manhattan distance. Okay, so these two are very common distance calculation matrices in statistics, either Euclidean distance or Manhattan distance. So that we have to fix. We have to use that same distance calculation method for all the iterations. Okay, so this formula will be given most of the times during exam also, which distance you are supposed to calculate, and that formula will be provided. So don't worry, don't memorize this, but this is for your understanding, that you have to fix upon whatever distance formula you are using. So using this formula, what we will do is, we will calculate the distance between the centroid and our data point. Yeah, distance between all C2 and X whatever, and C1 and X whatever, all the data points between both the centroid, and we will compare the this distance value. Whichever centroid is closest, I mean whichever distance is least, we will assign that point to that particular centroid. So say for example, from C1 xi, the distance of xi is 3, and from C2 the distance of xi is 4.5. So we will assign xi to cluster 1 or C1, because 4 is lesser than 3 is lesser than 4.5, right? So the closest centroid, that particular data point will belong to that particular cluster with that closest centroid. Yeah. So now we know that these many points belong to cluster 1 and these points belong to cluster 2. But now we need to compute new centroid. okay, this might not be closest to all the data points in this cluster, and C2 might not be closest to the all data points here in this particular cluster. So what we will do is we will calculate average of all data points belonging to that particular cluster. This average value will be new centroid. So same cheese we will repeat. Once we have this new centroid value, new C1 and new C2, we will again calculate the distance from all the data points to this C1, C2. We will again see from which centroid a particular data point is closest, and we will reshuffle the clusters. If this particular data point here is closest to C2 instead of C1, then in second iteration it will go here in the second cluster, and this first cluster will be like this. Now we need to recompute the centroid value, new centroid value. Now we will find average of all the new members of first cluster, all the new members of second cluster, and new centroid will be calculated, new C1, C2. So we started with जो भी C1, C2, then we recomputed new centroid C1, C2, then again as we go ahead we again recompute new C1, C2. So this process is iterative. This is iterative approach. So how long will you do this? Till your clusters are constant or your centroids are not changing. So since we are calculating average, so these conditions will be same. जब तक data points सारे clusters में are constant, their average will also be constant. So the centroid will also be constant, right? So either of the condition is matched, that centroid remains constant or all the data points belonging to that particular cluster remain constant, we will keep on repeating this. So that will be the constant centroid will be the new centroid for new clusters, and all the data points will be part of that particular cluster.
Thanks a lot. Thanks a lot.
So now now we can't just randomly think, no, what is the optimum number for yes, Srinanda, you can unmute and ask.
Hi, ma'am. So I just wanted to ask, in the last lecture, the example paper that was discussed was with 4 attributes. Can you tell me about how we calculate the distances? Like we can't see them on a scatter plot, and how do we calculate the distance, and how is the centroid, decided when it's more than 2 attributes?
Yeah, so we compare, like, see, x1, y1 is the general 2-dimensional thing. So when we have multi-dimensional x1, y1, z1, so we will compare x with x, y with y, z with z, like that we will go on. So each parameter is compared with all the data points of that, all the data points that particular parameter will be compared.
Achha.
So think of it as a 2D thing, or 3D or 4D or 5D. Yeah? So we generally talk in terms of features. So each feature, the value belonging to that particular feature, only that will be compared. You can't compare apple and oranges. You can compare apple ka size with other apple ka size. Yeah, so keep that in mind. Don't get confused. It's fairly simple. And nowadays you don't even, when you are practically applying, you don't even have to manually calculate. There are k-means calculator. You just need to feed them the data and they will give you the optimum number of clusters, which is k, like 2 means, 3 means, 4 means. They will do it for you.
But the elbow is also done.
Yeah, elbow is also done.
Okay.
Yeah. Yes, Bijoyji?
Yeah. Ma'am, good evening. I wanted to be clear about whether the centroid values we should also calculate, or we should exclude that from the calculation when we calculate the value of data points.
Okay, I think you have gotten little confused. We just have second question starting on this. So once we solve that question, if you still have this doubt, we will take up at that point, if you're okay. Because when we have example in front of us, this calculation, what to consider and what to exclude, that becomes more clearer.
Yeah, we only calculate the distance of data points.
Data points from centroid.
centroid.
Distance between each data point and centroid we consider.
Okay, thank you.
And between, see, because centroid is going to remain the same, right? So once we calculate that, you will be more clear about this.
Okay, thank you.
Okay, so we will move on to next part is like fairly simple. The other approach is hierarchical clustering or rule-based clustering, what we call also. So these there are two types of hierarchical clustering, either Agnes or agglomerative clustering, which is like bottoms up. Every data point is considered as one cluster, like each entity or each data point is considered one cluster in itself, and then the distance between them is seen. The closest data points are clubbed together at higher level into one cluster, and this process goes on. So you start from individual data points and then you merge everything into one single cluster at the top. So it goes like this. So we have these 7 data points, say. So these two are closest, so we are clubbing them in one cluster. These two are closest, clubbing them in one cluster. These two closest, clubbed them in one cluster. Now yes, any doubt? Vinuta ji, you have any doubt? You seem to be on unmute.
I'm really sorry. I didn't know it was on
fine,
unmute.
it's fine.
I'm really sorry for that.
Yeah,
Sorry everyone.
I thought you have doubt in this. No problem. So these two data points, they are closest, so we have clubbed them in one cluster. And since this data point is not closest to either of them, we keep it separate in one cluster itself. So now nextly we calculate if distance between these two clusters are clubbed together, then this point is closest to this cluster, then it is clubbed together, and finally these two bigger clusters are clubbed together to form one single cluster. So it is bottom up approach. And when we do it in reverse order, like the entire data set is considered as one cluster and then we separate them as we go down, then when we follow the reverse order, it becomes Diana or divisive analysis. When we divide the data set, divisive analysis, that's a top-down approach. So right now we won't be calculating for Agnes and Diana, we'll be just calculating for k-means. Okay, so if you find you're finding this confusing, don't worry. Nowadays there are tools for all these things. You just have to give your data. If you search online, I want to do hierarchical clustering, if you ask ChatGPT or Google Bard that you want to do hierarchical clustering and is there any tool available online which will help you doing it, they will give you n number of tools which will help you in doing this. So you don't have to learn to code or to calculate for all these things. There are tools available which will do it for you. So just try to understand the basic theory behind it. Okay, so this week's content is fairly simple. So we have kind of revised everything in a nutshell very quickly, and now we are moving on to the problems. Okay, so this, I think one point I forgot to mention about error functions when we were discussing k-means. No worries, we can discuss it now. So how can we there is objective function or error function, which is the distance between centroid and data point. So we'll have the minimum distance whichever gives us. So when we calculate the distance, when we consider squared error, that is squared distance, you remember x1 x2 the whole square is the distance formula. So when we are considering the difference and we are squaring it, then we are getting squared distance square for all the points. So when there is a difference between centroid and data points, that is minimum, that means they are closest. So the error of division or error of assigning the cluster is minimum. So we try to minimize this error, or that's why we call that square difference of distance between centroid and the data point ka square as error. Okay. So this error function, that means distance between centroid and data point squared is minimum when so let's try to read all the options. A says the data points are grouped into just 2 clusters. B says data points are grouped in 3 clusters. C, data points are grouped under 1 cluster. And D, the number of clusters and the number of data points are equal. So I have one person saying option C, rest of them are saying D. Okay, so let's try to understand.
Option D.
Sorry?
Option D.
Option D, yeah. So let's try to understand why it is not option C. So option C says data points are grouped under 1 cluster. So that means all these data points will be belonging to this one cluster with centroid C1. Yeah. So what error function is distance between centroid and data point. So C1 and xi square will have to find the summation of all the data points for all the data points, that distance between all the data points and centroid. We have to calculate their square and we have to sum it for all the data points in our data set. So when this will be minimum, difference between the data point and the centroid, when it will be minimum, when that data point itself will be the centroid, right? So the number of data points and the number of clusters are equal. Each individual data point will be a cluster in itself. At that point, the distance between that data point and centroid will be 0. So this error function will be 0 in this case. Yeah. So but what if our entire data set is only one cluster? So one cluster mein there will be some distance between all the data points and this one centroid. Yeah. So this summation will be, the distance will be maximum in that case. Because there will be only one data point. So some data points like which are on the periphery, they will have the maximum distance from this centroid, center point. So this is the case of maximum error function. And this is the case of minimum error function or 0 error function. Now these we'll have to verify, or we have to actually solve to see whether all the data points, whether we will get the optimum results for 2 clusters or 3 clusters. So these two options cannot be the answers. So why it will not be one cluster? Because for one cluster, the distance between centroid and data point will be maximum. The summation of distance will be maximum. And why this will have, the scenario D will have minimum error function value is because all the data points will be centroid in itself. So the distance between centroid and data point will be 0 and the error function will be minimum. Yeah. So the correct answer is option D. Yeah. So now we have come to from question 2 to 5. This is the theory, or these are the data points which we have to follow. So there are data points from A1 to A5. Their values is given. Now I am requesting you to sit with pen and paper, because this will require a lot of manual calculations. Yeah. So as usual, we will be doing calculations together. So please sit with pen, paper and calculator, so that we are speeding up with the calculations. Okay, so these are 5 data points: A1, A2, A1, A2, A3, A4 and A5. Coordinates are given. So right now we will call these data points as coordinates. Okay, I'm not reading this background because some teacher has collected some data regarding maths and science, how much you like it and how much you don't like it. So Likert scale is how much you like it, like you agree, you disagree, and something in between that. So 5 points is from 0 to 5. You can give any response on the scale of 1 to 5. What is your opinion? Those kind of questions this teacher has collected, and now she wants to divide the students into 2 groups so that she can tailor the content accordingly, adapt the teaching method accordingly. Yeah. So this is the distribution of all those A1, A2, A3, A4 and A5. Now initially these are the clusters, C1 and C2 are the clusters. Now what we are supposed to do is we are supposed to go up to 2 iterations to find new clusters and new centroid. And what we are supposed to use is this Euclidean distance formula. Okay, so ideally if you see, Euclidean distance formula is square root of this. But for ease of calculations, we are going to assume if squares have differences, then square roots will have similar differences. Yeah, like 2 square is 4 and 3 square is 9. So if we compare 4 and 9, the differences going to remain the same. Like 2 is also lesser and 3 is also lesser. Okay, so for sake of simplicity, we have removed this square root function. And for ease of calculation, we'll keep this square as it is. Okay, so now what we are supposed to do is we are supposed to calculate the new centroid points. Okay, so I am going to write all the points here: A1, A2, A3, A4 and A5. Now what is A1? 255331. 255331, then 1544, 1544. Okay, now we have to calculate the distance between both the centroid. Okay, so 4,2 and 3,5. 4,2, 3,5. So now what we will do is we will calculate the distance between them. Okay, so distance का formula you remember, x2 minus x1 plus y2 minus y1. So Shrinanda, the doubt you had asked how we will compare n sets of parameters is this: x compared with x and y compared with y. Okay, so x minus xc and yi minus yc centroid square is what we are going to follow. Okay, so now this is c1. Now distance between a1 and c1 is 4 minus 2. 4 minus 2 का square, so 4 minus 2 is 2. 2 का square plus 5 minus 2 square. 5 minus 2, 3. 3 square. So this is 4 and 9. So 13. Okay. So likewise we will do this calculation for all the data points. So it seems 1 square plus 1 square, which is 2. Then is this 1 square? Yeah, 1 square plus 1 square. 1 square plus 1 square is 2. Then 3 square plus 3 square 9. 0. 4 minus 4 0. 4 minus 2 2. 2 square.
It should be 18, no? 3 square plus 3 square.
Oh sorry,
No?
yes 18. Sorry, yeah, 18. Yeah, 18 2 4. Yeah, now it seems correct. Okay, so now we will calculate the distance between all these data points and centroid 2. So 2 minus 3 1 square plus
Square plus
0.
0 0. Yeah, right.
Yeah.
So 2 square plus 2 square.
Okay.
8 8.
Okay.
And 0 plus 4. Plus 0 plus 4 square, no?
Yes.
Next.
0 plus 4
16.
which is 16.
16. And 2 square plus 0. 4.
4.
And 1 square plus 1 square. Right? That's 2.
2. Okay, so now let us change the ink color. Okay, so now we will see which data point from which centroid has the minimum distance between 13 and 1. Which is the closest, C1 or C2 to A1? To which cluster it will go, C1 or C2?
C2.
C2, because this distance is lesser than this 13, right? So we will choose this. So similarly, A2 will be going to C1 or C2? Between 2 and 8, which will be the closest?
2, right? Is it like minimum we should see?
Minimum. We should see the
Yeah, then
closest.
2. Yeah, 2 then
Closest.
2.
So 2 is closest, so that means C1, right? We will assign A2 to cluster 1. Because 2 is shorter, we have to see the
8 is too
closest
far.
point, right? So between 2 and 16,
2.
2, which means C1 or C2?
2 means, how do you say that? C1, C1.
C1. Here I have
C1,
written.
C1. Correct.
C1.
And next is 4.
C2.
That means C1 or C2?
4. C2.
C2.
And next is 4 and 2. Like, yeah, next one. How do you say?
C2.
Which cluster?
C2.
4, no? 4 is.
Closest,
4 and
closest.
2 is closer. Okay. So 2 is closer than C2.
C2.
Okay.
Okay. So here we don't consider the larger value. We consider the smaller value, which is closest. Yeah. So the distance between the point, if you see cluster behavior, the points which are closer to each other, they form one cluster, right? The points which are closer. That means the distance between them should be minimum. So which is the lesser value, that data point will belong to that particular cluster. Which centroid is nearest? So we assign the value based on
Second
this.
value.
For
The
second?
value is C1. Yeah, I was about to say that. I'm sorry. The second
yes.
value is C1. It's written wrongly.
Where? Sorry.
Second
A2.
value.
A2 is C1.
Or in the same table which we have just now
Okay.
calculated.
Yeah.
The C1.
Okay, thank you.
Yeah.
Now it's correct. Yeah, C1, A2, A2. Now it is correct, right? 2, 3, C1, C2, C2. Yeah, now it is correct. C2. Yeah. Thank you so much for pointing that out. Yeah. So now what we are supposed to do is we are supposed to calculate new centroid. So how we will calculate the new centroid is we'll have to calculate the average of the data points. C1, the cluster, the points which belong to C1, A2, A3. So this will be new C1, this will be new C2. New C2 will be average of A1, A4 and A5. Yeah. So how do we do that? Plain simple जैसे mean or average we calculate, we'll try to follow the same thing for these calculations. Yeah. So
Ma'am,
yeah.
Ma'am, I have a doubt. Like, how can we choose the average of A2, A3, and average of A1, A4, and A5?
Because we are calculating the new centroid for them, so there are different these things, no? K mean, K median. So right now we are following K mean. Mean means average. That's why we are calculating the centroid as average of all the data points which belong to that particular cluster. Yeah. So that.
Ma'am, I mean average of A2 and A3. So like if we can choose the another one like A1, A2, A3, or either A4, A5. I mean average of A1, A2, A3, and another one is average of A4, A5. If it is possible.
Yeah, that's possible. See, so K means what it says is it's iterative process. You can choose first centroid randomly on your own. So in our case, like this example's case, the first centroid was these 2 points, no? 4, 2 and 3, 5. These are just 2 random numbers. What we did is we calculated distance of every data point from these centroids, no? This is distance from this particular table is distance from centroid 1, and this particular line is distance from centroid 2, and we see that particular data point is closest to which centroid. Yeah, we found out that.
Understood.
Yeah. So now we need to compute new centroid. Now we divide
Actually, ma'am, I haven't noticed that. Like, we have the 3C1. And the another 2C2. So that's how we calculate the average of these clusters.
Yeah. So
now, ma'am, it's clear.
It's clear, right? So now we
Yes,
will
ma'am.
move on to the next step. We'll calculate the average of A2 and A3 for centroid 1. So 5 plus 3 will be the new x value for C1x. 5 plus 3 and 3 plus 1. We are adding y values together and taking average of y. We are adding x values, taking average of x values. Okay, so 5 plus 3 divided by 2, 3 plus 1 divided by 2. So this will give us 4 comma 2 as centroid 1. So now we do the same thing with A1, A4 and A5. Okay, so add all the x values. So 2 plus
Plus one.
1 plus 4
Plus 4.
divide by
3.
yeah, and y value is 5
5 plus 5
5
plus 4.
plus 4 divided by
14 by 3.
14 by 3, and here it will be 7 by 3. Yeah, so we have to calculate up to 2 decimals, right? So
So 2.33 is 7 by 3. That is
yeah, 2.33 comma, what is 14 by 3?
4.666.
4.67.
We can say 4.67.
Yeah.
Yes.
Yeah.
Yes.
So this is C2 and this is C1. So now which option has our answer? ABC?
Option B.
Yeah, so this will be the correct answer. So everybody's calculation is matching with what we have calculated here.
I actually missed the
Yeah.
track of the second C2 calculation.
Yeah, so what we have done is we have found out the average of x values and y values belonging to second cluster. So which points belong to second cluster? A1, A4 and
A1,
A5.
A4 and A5.
A5. So we took their x values, which is 2 plus 1 plus 4, and divided that by 3 because 3 data points belonging to cluster 2.
Yes,
Yeah.
yes. Now I got it.
And similarly average for y values. So
Right.
that
Thank you,
gave
sir.
us this C2 ka value. So this is C2 and this is C1 ke coordinates, like xy values. Okay,
Yes.
so B is
Thank
the
you.
answer. Yeah. So now what is or are the data points that are clustered with centroid C1 after first iteration? So which
A2 and A3.
A2 and A3. So A2 and A3. Yeah. So now we have this new centroid value. Now the new question is regarding the second iteration. So what we will do is we will calculate the distance again. Yeah. So 2555331 2555331 then 1544 1544. Now C1 was 4 comma 2 and C2 was 2.33 4.67
4.67.
2.33 comma 4.67. Okay. So now we need to calculate the distance again using the same Euclidean distance square, difference ka square. Using the same thing we will do. Okay, so 2 square plus 3 square, right? 1 square plus 1 square, 1 square plus 1 square, 3 square plus 3 square, and 0 plus 2 square. Okay?
Yes.
So this 9 plus 4 13, 2 2, 9 and 9 18, 4. So we don't need to keep so much distance. Okay, so we'll just do this. Okay, so now 2 minus, so this will be 0.33 square plus
0.27.
5 minus 46, sorry, it's not 1. 5 minus 4.67, so it will be
0.33.
0.33.
33.
Yeah, 0.33 square. It will be again 0.33. Yeah, 3 and 3. Yeah. So it will be, this will be 2.67 plus 1.67 square. This will be 0.67 plus 3.67. This will be 1.33 square plus 0.33 square. This will be 1.67 square plus 0.67 square. Yeah. So what will be 0.33 square plus 0.33 square? So roughly
0.3898.
0.3, yeah, something 0.3.
0.3898.
3898. So we can write 0.39, 2 decimals, 0.39. This will be roughly around 9 point something. 9 point something or 10.0 something roughly, you know.
It's 9.9178.
9.9. This will be 3.5 squares. This will be around 11, yeah, 12 point something. 12 to 13 भी हो सकता है. Yeah, it is 12 point something. Let me know if somebody is calculating, or otherwise I'll use calculator.
Actually, 13.
So can I tell the root square value?
It's okay. I mean, if squares are different, roots will also be different in the same category, right? 9 will always be greater than
You don't get the
4.
value, proper value, without having the square root.
Yeah, I mean, yeah, if you're interested, you can do that. But what I'm following is for ease of understanding and for ease of calculations. If square,
Okay.
one square is larger, their square root will also remain larger. Yeah,
Yeah.
that's
We
the
actually
logic.
have to calculate. It's fairly understandable कि कौन सा कम है.
Yeah, that's true. That's true. The difference is too much, like, you know. This will be roughly 2.
13. No, the above one is 13.9178. 13.9178.
Okay, this will be roughly 2. This will be roughly 3 point something. 3 point something कुछ तो roughly आएगा. It will not be 4. Definitely the sum of these squares will not be 4. It will be less than 4.
And my submission is, if we don't get the square root value, how do we know that it converges with the first iteration result? If we get the whole square only, we cannot perhaps get the actual value, and then we cannot compare it with the value we get after first iteration.
Why?
In fact, it comes to the same.
Yeah, it may come to the same. That is where. So you remember when we were discussing how to perform clustering techniques, I had told you when to stop, because it's an iterative process that will go on, going on. So when to stop? When the members of the clusters remain constant, the data points which belong to one cluster remain constant. So it may happen that the elements belonging to one particular cluster, same elements will belong now also, right? So in that case, the answer will remain same, the centroid will remain same, the data points belonging to that particular cluster will remain same, and we will stop at this particular iteration.
Yes, ma'am.
So
that is 1.8778.
1.888778.
And next is 3.2378.
3.237. Okay, fine. So now I'm going to change the ink, and let us see which point belong to which cluster. Yeah. So this is 13 and this is 0.39 something. So A1 will belong to which cluster, C1 or C2? C2. Right. Now A2 has distance of 2 and 9.9. So it will belong to which cluster?
C1.
Yeah. Now A3 has distance of 2 and 13.9. Now A4,
C2.
C2,
C2.
A5, C2.
C2.
A5 is, yeah.
C2. Yeah. So we have found the clusters to be same, right?
Yeah.
Our first iterations, the clusters were also same, like A1 A2 belonged to cluster 1 and A2 A3 belonged to cluster 1 and A1 A4 A5 belonged to cluster 2. Same thing is here, like A1,
Yeah.
this is cluster 1, cluster 2, and this is cluster 1. So our centroid will remain same because the average of all these points is going to remain same. Yeah, so it will be if I correctly, so same, no, 4,2 C1 and C2 will be 2.33, 4.67.
4.67.
So which option will be the answer?
D.
Ma'am, the second one.
B.
Option B. Yeah.
Option B seems to be closest, but it has to be 3.22. So let's agree that
C.
B seems to be closest, so we choose B, but it has to be 2. Yeah, this is just 2. We want it to be 2.33. Yeah. So this seems to be closest answer.
Typing error.
Yeah, maybe. Yeah. So we will go to next question. Next question says clustered with centroid C1 after second iteration. So C1 was A2
Ma'am,
and
A2 and A3.
Yeah, A2 and A3. Yeah, so this was simple, like very easy calculations, is plain arithmetic, nothing more. Yeah, so rest of the questions are very simple. Now choose the hierarchical clustering methods from the options given below. There are just 2 hierarchical clustering methods, and I think we spoke about them in the beginning. C, correct answer, and there is one
A
more.
and C.
A and C. Yes.
Agglomerative nesting.
So agglomerative nesting, short form, anyone remembers?
Agnes.
And divisive analysis, short form, anyone
Diana.
remembers? Diana. Yeah? So Agnes and Diana you have to remember for hierarchical clustering. Okay, now question 7, which is true about Agnes method. Yeah? So we
Ma'am, bottom up approach.
Okay. And
Each data B.
And B, ma'am.
Okay.
B and D.
B and D.
Yes.
Yes, ma'am.
Somebody said bottom up approach, right? So D. So everyone is on same page, no one has any other confusion?
Ma'am, B and D.
Okay, great. So no confusion. We can move on to question 8. So for question 8 and 9, this is the dendrogram we have given. So distance between the clusters is y-axis and x-axis has these are the individual data points. Okay? So we'll come back after looking at the question. How many data points are represented in the
Ma'am,
dendrogram?
6.
So how many?
Ma'am, 12, not 6.
Okay.
Is it considering the bottom points, right? ma'am?
Bottom points, yes. So doesn't matter what approach we are taking, whether it is top down or bottom up approach, the end points are individual data points. So what we will do whenever we have to read a dendrogram, which are the last leaves of the tree, so we call it leaves of the tree, and this is root. So we will count how many leaves a particular tree structure has. So this tree has 12 leaves. So that means there are 12 data points which are represented in that dendrogram. Okay? Understood? Because even if it is top down approach, we consider it as one cluster and then we are dividing it, and then finally at the bottom it comes down to individual data point. Yeah, so even if this dendrogram is generated using Agnes or using Diana, it doesn't matter. So we are not
Could please point out the leaves?
Yeah, these are the leaves, the end point where there is no further division, it is the last.
Okay.
So
Yes,
no
this-
matter where the line is, only you should consider the leaves, the bottom.
yeah, the bottom
points.
where the division stops. Where the division stops. There is no further
No.
division.
So example, the line is above that.
This line.
If it's above also, consider it's above that.
So
Yeah.
so next question is about that only. How many clusters are formed by dashed in dendrogram? So what we will do is we will. So this is one cluster, right? Here we will not.
Total three cluster.
No. Okay.
I
Wait,
see.
wait, wait. So I will again do, huh? So we have how many leaves now?
Ma'am, 6 leaves.
6,
Yeah. So how many clusters are at dotted line?
12.
No.
3.
This no. Okay. Now I think there's a lot
At the
of
bottom line.
12.
not at the
4,
bottom line,
6,
at the
8.
dotted line. I'm sorry.
Okay. So,
Yeah. At the
dashed
dotted line.
line 6.
How I will tell you. 6 is correct answer. Okay. So this one leaf is one cluster here, right? This one cluster is this one leaf, right? This one cluster of these two data points. These two data points belong to one cluster, and this one cluster represents this leaf here. And this is the C1 with X1 and X2. Yeah. So this is C1. Similarly, for these two data points, this is C2. For these two data points, this is C3. These two data points, C4. These two data points, this is
5,
C5. These two data points, this is
C6.
C6. So how many clusters at dotted line?
6.
6.
6 clusters. And how we get there? We calculate the number of leaves at that particular dotted line. Simple to understand?
Okay. Yes, ma'am.
Yeah, 6. So if we are so what, how many clusters are there at this dotted line?
3.
3.
3 clusters. Okay, this one cluster, this one entire one cluster, and this entire one cluster. Now if I have dotted line over here, how many clusters are there?
2.
2. And here how many clusters are there?
1.
Which is the entire data set as one
1.
cluster.
Yes.
Okay. So last question, what is the optimum value of k chosen from below figure? So this is the sum of squared distance, which is the error function on x-axis. Sum of squared distance. And this is the number of k. So where is the elbow lying here?
6.
6.
Because after that this value of error function is not that
Dropping
much
rapidly.
different. No? The difference between the j value or the error function value is not that much. If you see here, difference between 4 and 6 is high. Difference for error function for 4 and 6 is high, but difference between error function for 6 and 8 is not that high. I mean, this is not that high compared to this, right? So that's why the elbow occurs at 6. So this is often referred to as elbow curve, and whenever the elbow or the sharp bend is happening, that is your answer.
Ma'am, can you give the another example of elbow function? Maybe it will better for me. I mean, for understand.
I can't give example. We'll consider another graph maybe.
Yes, ma'am.
Yeah. So let us consider 1, 2, 3, 4 and 5. Yeah. So this is say 24, 25. This 2 के लिए let us say there is 16. For 3 let us consider 9. For 4 let us consider 4, and for 5 let us consider 5, for 6 let us consider 0.5. Yeah, and let's try to map and try to find the k value for this particular map. So for 1, error function value is 25. For 2, error function value is 16. For 3, error function value is 9. For 4, error function value is 4. For 5, error function value is 1. For 6, error function value is 0.5. So how we can calculate is, what is the elbow curve here? What is the optimum value for k for this particular graph? Anyone wants to guess? Yeah, what?
0.5. Is it 5?
So 5 is correct answer. We will not consider 0.5 because 0.5 is y ka value, na? We should consider what is there on the x-axis. Y-axis will have error function or squared squared distance. Yeah, this is the number of k on x-axis. So the k value should be from x-axis. So even
1.
No, this is from this, no, y-axis. We have to go for the x-axis ka value. So 1 seems to be correct answer. So 1 ka corresponding x value is what?
5.
That is our answer. Okay, so you have understood the concept. We will consider the differences between this value on y-axis. But when we have to give them optimum value of k, where is k? On x-axis, no? So we will consider that corresponding x-axis ka value. Yeah, understood?
But the difference between y-axis values 4 and 1 is 3. The difference between 1 and 0.5 is 0.5. When there is a minimum difference between the y points, that point we should consider for elbow curve, no?
Yes. So 5 is the point from where the difference starts converging or the difference starts minimizing.
Okay, ma'am.
Yeah? So see, when we want to walk towards having the perfect centroid, minimum error value, when is that going to happen? When individual data point is one cluster. Do we want to do that? Then what's the whole point of clustering? Consider every data point separately as one single entity. We want to cluster data points together. So where we will stop is this particular value of 5, from where the error function starts converging.
Okay.
So how you will find where it is converging? We'll consider difference between this y-axis. When that difference is getting minimum, and when that difference is not so different, like the difference between 4 and 1 is 3, difference between 1 and 0.5 is 0.5, difference between 1 and 9 is 8, difference between 4 and 9 is 5. So this is high difference. But whereas difference between 1 and 0.5, and we go so on. So that's why this value is like this, no, downwards curve. And whenever the sharp bend happens is our k value. Here is our k value and here is our j function. So this particular value is our k value. Okay. Now it is clear, or any
Yes,
confusion?
it's very clear.
It's clear.
Thank you.
Yeah.
Okay, ma'am. Ma'am, I have another question. Like whenever we are just calculating the new
Centroid?
the new centroids. Like if one of the value of the centroids, like previously, whenever we have just seen and we have just calculated the distance are same for A2 and A3. So that's why we are just stop the iteration process. So ma'am, it will possible for the both value will be same for the next iteration whenever we are just calculating.
It is possible, because see, when the distance between centroid and your data points is not here this value of these values 13 to I'm sorry. Yeah, these values 13, 2, 2, 18, 4 are different. And here, these values are 13, 2, 2, 18, 4. These are different, no? Oh, no, these are same. Maybe I should consider this value. Yeah, because that centroid value 4, 2 is also same. So this 1, 8, 16, 4, 2 is what the difference between data point and centroid. And here, the difference between data point and centroid, 0.39, 9.9, 13.9, 1.8 and 3.2. So this difference is different. Yeah, but still the centroid remains the same because the points in the cluster remains the same. How we calculate new centroid? We average the points in the cluster. We found out the C1 and C2, new C1, C2 value by taking out average of the points which belonged to C1 and which belonged to C2. This 2.33 and 4.67, it came after averaging 2,5, 1,5 and 4.4. And this 4,2, it came after averaging 5,3 and 3,1. So when the members in the cluster remains the same, our centroid value will be constant.
Okay, ma'am.
So Saurabh ji, I am not going to answer this question because this is the only question which is new in this year's assignment. So I will not be giving you answer. Instead, you tell me based on our discussion what should be the correct answer. Because most of the questions are as it is same in all the assignments, almost 90% questions are same.
ABC.
ABC. No, I'm waiting. There are few people who are answering just A and C and not B. So I'm waiting for that question to come. Okay, why B or why not B? Okay, so nobody is asking that question. So those who have who think that option B is not really needed for k-means clustering, do you have any justification for that why we don't need to define number of clusters beforehand?
This k-means clustering means we can choose first random thing and merge with the closest one.
Yeah.
Right.
Yes.
So
Yes.
number of clusters, whatever thing, so it comes under that part.
Yes.
So, but why is Elgo done anyway? Elgo is done to fix the number of clusters anyway.
So now, so we don't need number of clusters. We can start with any number of clusters, or we should start with some certain number of clusters. What do you think?
We should start with the random thing and point, and then whichever is nearest thing, make it cluster, like form the cluster, right?
Yeah. So there are two approaches to doing this. What Varun you are saying is also right, and what Shriyanda is saying is also right. Nothing is wrong. So see, why we have to understand why we are performing this clustering exercise on our data set. So one of the purposes which we discussed was Niva, can you please mute yourself? Yeah. So one of the reasons which we discussed was we want to create some students' profile so that we can personalize the messages, the questions, the content accordingly. So in that case, how many profiles we want to have is decided by us. That means number of clusters is decided by us, right? We will try to group the students into those many number of clusters. So in that case, we begin with the number of clusters, that we want to have 4 different clusters based on 4 different behavior patterns. One cluster for students who perform well in the quiz, but who spend less time in going through the content. So second cluster we want for the students who are performing well in the quiz and who are giving adequate time to the content. Then cluster 3, who are giving adequate time to the content but are performing poorly in the quiz. And fourth cluster, students who are not performing well and who are not even giving adequate time to the content. So we have in mind that we want to have these 4 profiles. So we try to create these 4 clusters based on students' log data or students' feature engineered data. So in that case, we have the number of clusters defined with us. But what happens when we have huge number of data and now we have to see how many students actually behave similarly, how many clusters we can get out of that data. So at that point we will start with k is equal to 1 and we'll go to k is equal to 50 and we'll try to plot the j curve, and then we will come to that optimum k value ki, okay, for this cluster, I mean, yeah, these many groups we can have for our given data. So purpose of clustering activity will decide whether we are beginning with number of clusters or we are finding the optimum number of clusters. So based on our purpose we will decide that. So neither of you is wrong and neither of you is completely right. Yeah.
So what is the option? What is the answer?
So for this we will consider B also, we'll begin with the number of clusters, because for analysis point we don't want to start with k is equal to 1 and end with k is equal to how many data points we have. Suppose we have 500 data points, then at the end will we be going to 500 different clusters? Will we be going till that point? I don't know, because for each k we have to do this centroid computation iteratively. So just imagine if we have to do it for 500 students, how many iterations of k means we have to go. Yes,
Ma'am,
Nima?
is there any rule for centroid assumption? I mean, initially when you assume the centroids on the basis of what you said, the four major groups you have decided. So can you start from any random, or is there any rule? Because
So it
currently
is
groups
again
very,
advised.
closely, I mean, they will be differentiated with a close margin and all. So in that case, how do you select? Or it's just random, you start and then?
So again, whenever we say that you have to start randomly, you have to do educated guessing. If you start with numbers which are too far away from your groups, then you have to do more iterations to get to the proper centroid value. But if there is a visible, you draw a cluster plot for this. I mean, you plot cluster graph for your data, and then you can see 2 distinct clusters or 3 distinct clusters happening. Then you know that optimum k value will be 2 or 3, and then you can roughly see where the clusters are happening, and if you take a point within that cluster as your starting centroid, then you have to do less number of iterations to come to the actual centroid of that particular cluster. So this is, again, if you want to reduce your labor, you take an educated guess for your first cluster point. But if you don't care about it, then you take any random numbers and start calculating. You will eventually get to the same centroid. What matters is when we are manually calculating the number of iterations. But you don't have to worry about that, because I have been repeatedly telling this, there are tools for cluster calculations. So you just have to Google online k-means cluster calculator. It will just ask for your data points and it will give you everything, like optimum number of clusters, the centroids, and you can also decide how many iterations you want to perform on that particular data set. So you don't really have to worry about this having the optimum calculations done part.
Now,
Nowadays.
can we directly use that orange tool
Yes.
for doing all these things?
Yes.
Amen.
Yes.
I
you can
have
try.
one question actually, ma'am.
Yes.
So in the lecture actually we were said कि आप centroid computation करते हो after choosing your k. So for k basically we will need to choose some initial centroid. While doing the elbow, we'll have to do some initial centroid choosing. So वो हम कर लेते हैं. उसके बाद we do elbow, and again after completing your elbow, you choose your k, and then again do centroid computation.
No, you don't need to do centroid, because say you consider k value from 1 to say for example 8. 1 to 8 tak you have already calculated for k size of clusters, I mean number of clusters 1 to number of clusters 8. You have already done the computation, then only you have gotten your error function value, right? Error function is what distance between your centroids and the data point, sum of the distance between centroid and each data point belonging to that particular cluster. That you will calculate for one cluster. that you will calculate for 2 clusters separately, then add them together, then you will do it for 3 clusters separately, then you will do it, and so on and so forth for 8 clusters. So you have to
Crazy,
compute the
actually.
clusteroid first in order to get to the error function.
Okay.
So
Yeah,
error
yeah.
function remains the end step. So after error function, you have found the elbow and you already have done all that calculations before.
Yeah.
So you just
crazy.
go back and pick up those clusters. I mean, yeah, and those centroids.
Got it. Thank you.
Ma'am, whenever the question is asked from the K-means clusters, so the points like we have solved here the problem. So like the centroids and the other, the A1, A2, A3, A4 and A5 and the other, like it will be given.
Yes, yeah. So
And the already and the formula of Euclidean distance, like and the formula is also given.
yeah, mostly
use
formula will
this.
be given, or
Okay.
there are just two distance formulas which are majorly used. One is Euclidean distance and one is Manhattan distance. So Euclidean distance is like if you consider yeah, this to be x1 y1 and
Ma'am, whatever, Euclidean and the another one. So, like, they are just mentioning in the question, like, which one we have to use.
yeah, mostly the formula
Okay.
will also be given. How to do is, so Euclidean distance is they follow the Pythagorean system, na? The square between the x1 y1, and Manhattan
Yes,
distance
ma'am.
is like this. You start from here, come here, and go there. So you will find difference like this. So this will be Manhattan, and this direct difference will be Euclidean. So either of them, formula for them will be provided like this. So data point will be provided. Mostly the initial centroid will also be provided. Then only we can have some MCQs. No, if you randomly choose, if we ask you to perform, there is no way to check these table calculations for each and every one. No, mostly MCQ. So you will get all the information. You will just have to calculate and see if your calculations are matching with the options given. So don't
Yes,
worry.
ma'am.
Negative marking in the exam?
Sorry.
Do we have negative marking in the exam?
No. As far as I know, NPTEL doesn't have negative marking. Don't worry.
Ma'am, but whatever question, like the question pattern, we will get from the previous answer. Previous year question and this year question. So, like the first iteration and the whatever the question they will be provided. So, like we have to solve the, one by one, like the distance from, the new centroids to A1, A2, and this one also. So, like we have to calculation all the things, and after that, like we have to go for the second iteration. If it will remain same, so we don't proceed for the next iteration, or if it will not same, then we will go for the next iteration.
Yeah. So you don't have to worry about that. It will be mentioned in the question. Like here also, they have mentioned you have to go up to only 2 iterations.
Okay, ma'am.
That information will also be provided from exam point of view. So don't worry. You guys are stressing so much over type of questions and all here. Don't worry. Just try to understand. Keep your fundamentals clear. Then you will be able to solve anything with any information. Don't worry. Be confident.
Yes, ma'am. The question solving part is most important. For the mathematical problems only, because
See, this maths
here
is so simple.
whatever.
It is just subtraction and
No,
squaring.
ma'am.
That's it.
It's okay. No, ma'am. I am just saying, like, maybe whatever question or whatever data points they are providing in exams, the points will be the different. So I have to know the process how to
You will be
calculate.
able
Then
to
it
do
will
it.
be okay.
Yeah. So now we
Yes,
did it.
ma'am.
We did the solving and everything. Now, so you know what you have to do. Even you told me that do we have to calculate
Yes, ma'am.
the square distance and everything. So you have now understood how to do it, how to come up with this table. That is important.
Yeah,
Numbers
ma'am.
will change. That you will be able to handle. Don't worry.
Actually, whenever I have just watching the videos, so it was like I am so much confusing, like how they are just calculating. So that's why, like whenever you are just solving the problem in the discussion time, I mean, so I mean it will be more clear to me. And whenever I am watching video, like it was a little bit doubt to solve this problem.
Yeah, that's why I ask you to watch videos and come, so that you can ask those doubts, the problems or the points which you did not understand, you can ask here. So now I hope, Shreya, you have understood the process of how to
Yes,
compute the
ma'am.
centroid and everything. That's
Yeah,
clear,
ma'am, it's
right?
clear to me.
Okay, great, good to hear that. So I'm assuming there are no more doubts.
Ma'am, go to question 1.
Question 1. Okay. Question 1. Yeah.
The last part in the number of clusters and data points are equal.
Yeah.
Uh,
So we had enough discussion. So what is the confusion, Varun, here?
only the last part, that the fourth option, that
You
is
did
the
not understand.
minimum number of clusters. So
Okay.
number of the error function is 0, is it? No? That part.
Yeah,
is
it will be
clear.
0. It will be 0.
Okay. Okay.
Why it will be 0? Because
Hmm.
every data point will be centroid, right? If every data point is individually a cluster, then what will be the centroid for that cluster?
0.
That data
I mean-
point itself.
Okay, got it. The
Then
main
the
point.
difference between centroid and data point will be 0. So error
Zero.
function will be 0.
Okay.
Yeah.
And
got it?
this thing will be distance will be maximum for under one cluster. The
Under
root
one
under one cluster.
Right. Yeah, it will be maximum. Because this is the formula for error function, no? That's what we have. Difference between centroid and the data
Centroid
points.
and
So if all the data points are part of only one cluster, then that will distance that may go to the maximum attainable value. It because the centroid ideally would be somewhere in between these data points, no? So that's why. If you start with some random cluster over here for first iteration, your cluster is here, your data points are here in this cluster, then it is different, like out of them. But the actual convergent, like average of all the data points cluster, even for that actual centroid, this will be not be 0 under any circumstances for one cluster.
Oh. Yeah, thanks.
Ma'am, in the same question, in k-means clustering, the value of error function is, I mean, what is the max? I mean, is there any maximum value where, I mean,
Yeah, that's
when
what
the
I was
error
telling.
function is occurred?
Yeah, that's what I was telling. So for this cluster, in this cluster, like which I'm I'm just doing dotting, and if I consider this as centroid over here, the star marked, which I'm making it dark over here, then that value will be more than if the cluster is inside this over here. Yeah, so there is no cap on what is the maximum value to which error function can go. But it can't be, it can go up to 0. Yeah, the minimum value has to be 0. Maximum value could be like anything.
Then the option D is the right answer, ma'am.
Ma'am, we cannot calculate the maximum value for the error function in k-means clustering.
How you will calculate? If you don't know the clusters, how you will calculate? If this is the given information you have, like in k-means clustering, what
Okay,
is the
ma'am. I
maximum?
mean, data is inadequate.
Data is inadequate in that case. But for all the, like, if the number of clusters are equal to number of data points, then we know that each data point will be centroid for that cluster, and difference between centroid and data point will be 0, and that's why the error function will also be close to 0.
Okay, ma'am.
So should we stop? No more doubts seem to be coming.
Yeah, ma'am, I don't have any questions. Thank you.
Okay, great. So today's week was really, I mean, we could finish it very quickly. The doubts were cleared very quickly. So it was a good session. So I hope next week, please watch the video so that we can, like today's session, we can have the pinpointed discussions regarding doubts or, some difficulties in understanding some concepts. We can target that. So
Yes, ma'am.
so I really enjoyed today's session, because in the beginning everyone said that they have watched the video, so I just quickly gave the overview when we moved to the assignment questions. So it was a good session. Okay, so see you all next week. So ending this meeting now. See you next week.